Hello. In this video, I thought that we would find the antiderivative of another kind of common trigonometric function. Last time we did tangent of x. This time we'll do cotangent of x. And as you'll see, this derivation, derivation is kind of a misleading word to use, though it's correct, but it kind of implies differentiation, which is something different. This anti-differentiation we're going to be doing, or derivation of the antiderivative, it's going to be very similar to the last one, and that's a bunch of unnecessarily confusing words, but we'll go with it. So to start off with this antiderivative, and we're doing an indefinite integral, we have the integral of cotangent of x dx. That's going to be the same thing as the integral of cosine of x over sine of x dx. And this is where we're going to pull out the u-substitution, just like last time. This will probably be a pretty quick video because a lot of the steps are similar to, or identical to what we did in the previous video. So what I'm going to say is hey, look, there's this function sine of x here, and there's its derivative up here, so maybe we can do something with that. I'm going to say sine of x is equal to u, or even better, u is equal to sine of x, so du dx is equal to cosine x, so that du is equal to cosine x dx, and voila, we're going to have a derivation that's even easier than last time because, look, we've got this, and we're going to use yellow because reasons. This corresponds to this, and this corresponds to this, so we can just plug u and du in for those things. So now this whole integral just transforms into the integral of, we have du over u, which is the same as the integral of 1 over u du. And if you're familiar with the common antiderivatives, it's just good to know, or you're familiar with derivatives, you'll know that this is the natural log of the absolute value of u, but since we plugged in u, it's a substitution, of course. We know that u is actually the sine of x here. We're going to bring that down, and we're going to make this equal to, we should probably have this red anyway. Let's just make this all red, because it'll help with visual presentation. Okay, natural log of u. We're just going to plug in what u actually is in terms of x. Well, u actually is u, but what it is in terms of x is going to be the natural log of what was u? That was sine of x, so the natural log of the sine of x. That's going to be the antiderivative of the function cotangent of x. How can we demonstrate this clearly? Well, just like in the last video, we'll take the derivative of this function here. If our function up here, f of x is equal to this integral, then we find that f of x is equal to this. So then the derivative f prime of x should equal cotangent of x, right? That's just looking at, the fundamentals of calculus, literally like the fundamental theorem. So our derivative should just be that inner function there. Okay, so how do we do that? Let's just take the derivative. Let's take the derivative of what we found, and we should get cotangent of x. And hopefully that is indeed the case. And of course, I forgot the constant again because silly me, but there's a constant in there. When we take the derivative, that's not going to matter. But for the previous step, this is the full answer. This is a full answer. You need to include the plus c, but for finding the derivative of this, it's not going to matter. I'm going to show that you get cotangent of x. Okay, so let's do that in a different color. I'm going to do it in orange. So we have derivative with respect to x of natural log sine x. What's that going to be? Well, look at the outer function, natural log of x. We're going to take the derivative with respect to the inner function. That's going to give us 1 over the absolute value of sine x. We keep the inner function in there, but we pretend it's like just a normal variable like x. Now we multiply by the derivative of the inner function. And hopefully I convinced you in the last video that the derivative of the absolute value function, as thinking of it as an outer function, is going to be the absolute value over the value within those values, right? If you think absolute value of x, if you think like g of x, I'm going to write this up here, is equal to the absolute value of x, think about what the derivative is. G prime of x is going to be equal to the absolute value of x over x, and you can watch a previous video or just kind of think through that. But that is the case, and that's what we are going to be using in finding the derivative down here. And hopefully that's somewhat clear, because of course we are doing the chain rule. So now after this step, we've done the absolute value function derivative. Now we just need to multiply by the derivative of the inner function. That's going to be the derivative of sine of x, which is going to be a nice cosine of x. And how wonderful is that? These cancel out. We get 1 over sine of x times cosine of x, which is equal to cosine of x over sine of x. What's that? That is, of course, equal to our lovely old cotangent of x. And that is my demonstration that the integral that we took is accurate, because when we took the derivative of our result, we got the function that we were taking the indefinite integral of in the first place. I hope that this video was in some way informative, and thanks for watching.